Okay, so after finishing 4.7, we're gonna go straight to 4.9. No, I'm not gonna do 4.8, okay? It's not required. It's optional. 4.9. It's about antiderivatives. Antiderivatives are also called indefinite limits, as we will see later on in chapter 5. So basically 4.9 is an introduction to what we're going to see in chapter 5. So let's go over an introduction first. So if f of x equals x to the 4, then its derivative f prime of x equals 4x cubed. Now we say that by definition an antiderivative of 4x cubed is x to the 4, since the derivative, as we saw, of x to the 4 is 4 cubed. So it's walking backwards. If the derivative of f of x is 4x cubed, then antiderivative of 4x cubed is x to the 4. Okay, so let's build on that. So the original function is going to be little f, and then antiderivative of little f we're going to use as big F. So an antiderivative of 4x cubed is, as we saw, is x to the 4. Another antiderivative of 4x cubed is x to the 4 plus 1. Right? Because the derivative of x to the 4 is 4x cubed, and the derivative of 1 is 0. So you can see now, when we do derivative, we're finding the slope of tangent line. When that exists, there's only one slope of tangent line. When we're doing antiderivative, there's more than one answer. There's actually infinitely many answers, because that could be x to the 4 plus 2. That could be x to the 4 plus any constant. Okay? So there's infinitely many antiderivatives for a given function, when those exist, of course. So let's define what we mean by antiderivative. A function big F, okay, we're talking about this one, is an antiderivative. And we're saying n because there's infinitely many antiderivatives for every function of little f on an interval I, if the derivative of big F is little f of x for all x in I. And if we have two antiderivatives of the same function, if we have two antiderivatives of the same function, they must differ by a constant. The constant could be 1, could be 2, could be who knows. Okay? If there are two derivatives for the same, two antiderivatives for the same function, if big F is an antiderivative of little f on I, and big G is an antiderivative of little f on I, then they differ by a constant. F of x minus g of x equals c, or g of x minus f of x equals, as you can see from two antiderivatives of the same function, two antiderivatives of the same function, two antiderivatives of the same function. Okay. So what now? In 4.9 in your text, they do not introduce the notation yet, but I will introduce it now. I think it's convenient. So what notation do we use for antiderivative? So let's recall what we just talked about right now. Big F is an antiderivative of little f on I if the derivative of big F is little f of x on I, for all x on I. And if antiderivative of f of x equals big F of x if f prime of x equals f of x. Okay. So to write antiderivative of little f, we use this. It's like a stretched s. It's like a stretched s. It's antiderivative, or later on we're gonna call it indefinite integral of little f of x. Now when we do derivative, we say it's derivative with respect to x. Same thing here. dx, which means derivative, antiderivative with respect to x, is big F of x plus c. That c, remember, that means we have infinitely many antiderivatives for each function. And this gives you the most general one. So just the example we did early on, antiderivative of 4x cubed dx. It's x to the 4, could be 1 plus 2, so we just write plus c. So now let's discuss the antiderivative rules or integration rules based on the derivative rules. And I have a handout for this. And actually there's a couple more. This goes up to 14, but on this side, which is not included in your notes, because I scanned the notes and I'm sure this didn't scan, but I'm gonna write them down for you, okay? So, derivative rules, antiderivative rules. Or integration rules, okay? We know that the derivative of a constant is 0, so the antiderivative of 0 is a constant, okay? If we know that the derivative of kx plus c, where k is constant and c is constant, is just k, so antiderivative of k dx is kx plus c. So, for example, and we'll see why in a minute, integral of 5 dx is 5x plus c, because derivative of 5x is 5 plus derivative of c is 0, so we get that. The derivative of any constant times a function is constant times derivative of the function. Same thing. Antiderivative of constant times f of x is k times antiderivative of x dx. So if we have a constant, we pull it out. We could pull it out. Derivative of the sum or difference of two functions is the derivative of the first plus or minus the derivative of the second. Same thing with antiderivative. F of x plus or minus g of x. It's antiderivative of f of x plus or minus antiderivative of g of x. Remember, we have a product rule and quotient rule for derivatives. There's no such things for antiderivative. So there's no product rule, no quotient rule for antiderivatives, okay? Only for derivatives. Power rule, derivative of x to the n is nx to the n minus 1. So we times by the power minus 1 from the power. Now this is gonna undo it. So we start backwards. Instead of minusing 1 from the power, we add 1. Instead of timesing by the power, we divide by the power, as long as n is not negative 1. Meaning integral of x to the negative 1 dx. If you do this, you get x to the 0 over 0. That more, okay? So for instance, if we're doing integral of x to the 7 dx, it's x to the 7 plus 1 over 7 plus 1 plus c, x to the 8 over 8. Let's check our answer. We can always do that. So the derivative of x to the 8 over 8 plus c is 1 over 8 is a constant. Derivative of x to the 8 is 8x to the 7 plus derivative of c is 0. So it is x to the 8. Let's try another one. Say we have integral of 1 over x to the 6 dx. Well, to use the power rule, it should be x to the negative 6 dx. Okay? And then we add 1 to the power, divide by negative 6 plus 1 plus c, x to the negative 5 over negative 5 plus c, which is negative 1. I'm going to bring this down, x to the 5 plus c. Okay, so let's go back to the rules. Rule number 6. We know that the derivative of sine x is cosine x. So the antiderivative of cosine x dx is sine x plus c. We also know that the derivative of cosine x is negative sine x. So the antiderivative of sine x dx is negative cosine x plus c. Okay? So rule number 8. The derivative of tangent x is secant square x. So the antiderivative of secant square x is tangent x plus c. The derivative of cotangent x is negative cosecant square. The antiderivative of cosecant square x dx is negative cotangent x plus c. The derivative of secant x is secant x tangent x. The antiderivative of secant x tangent x is secant x plus c. And then the derivative of cosecant x is negative cosecant x cotangent x. So the antiderivative of cosecant x cotangent x is negative cosecant x plus c. So it's reversing the rules of derivative. We know that the derivative of e to the x is e to the x. Antiderivative of e to the x is e to the x plus c. And derivative of a to the x, where the base is not necessarily e, is a to the x ln of a. So instead of timesing by ln of a and the antiderivative, we divide by ln of a. Derivative of ln absolute value of x is 1 over x. Antiderivative of 1 over x dx is ln of absolute value of x plus c. Now, let me take you back to rule number 5. We said integral of x to the n dx. It's the power rule as long as n is not negative 1. Because if you do negative 1, you get over 0, it's undefined. So that's exactly the rule for negative 1. When you have negative 1, you're going to get what? N of absolute value of x. So when the exponent is anything other than -1, you use power rule. When it's -1, it's going to be natural. Okay. Rule number 15. The derivative of tangent inverse x is 1/1 plus x squared. So the antiderivative of 1/1 plus x squared is tangent inverse x plus c. And then the derivative of sine inverse x is 1/√1 minus x squared. The antiderivative of 1/√1 minus x squared is sine inverse x plus c. That's for now. There's going to be more rules later on. Okay, so let's do some examples. Some more examples. Number 8, page 361. It says find the most general antiderivative of the function. So what is the antiderivative of 6x to the 5 minus 8x to the 4 minus 9 squared dx? So since it's addition subtraction, we split it up. We can do that if it's addition or subtraction. We cannot do it if it's multiplication or division. There's no product rule, no quotient rule. We know if there's a constant, we pull it out. Minus 8 integral x to the 4 dx minus 9 integral x squared. Now it's all power rule, so we're going to add 1 to the power and divide by 6. We're going to add 1 to the power and divide by 5. Add 1 to the power, and then we can add a constant to one of them, but they're all constants, so we'll just add one constant. So we get x to the 6 minus 8x to the 5th over 5 minus 3x cubed. Don't forget the plus c, because that gives me the most general one, which includes every single antiderivative, because there's billions of them. Okay, here's an example. Again, what is an antiderivative of x to the 3/4 minus 2x to the square root 2 minus 1 dx? Again, we're going to split it up. So integral of x to the 3/4 dx. I'm going to pull the constant out so I don't have to do it twice. Right? Power rule says add 1 to the power and divide by the new power minus 2, and then add 1 to the power, divide by the new power, which is root 2, as these cancel out, plus c. So this is 3/4 plus 4/4 is 7/4. We're going to divide by 7/4 or times by its reciprocal, it's easier. Minus 2x square root of 2 over square root of 2 plus c. Okay, another example to find the antiderivative of 3t to the 4 minus t cubed plus 6t squared over t to the 4 dt. Now we know we don't have a quotient rule for antiderivatives, so we are going to have to get rid of that quotient. We can do that by splitting it up. So do some algebra first. Minus t cubed over t4 plus 6t squared over t4, which is 3 minus 1 over t plus 6t to the negative 2. We always want to put the exponent on top, so we can do the power rule. Now we're going to split it up. Integral of 3 dt minus integral of 1 over t dt. 6 will come out, it's a constant. And we have a rule for integral of k. It's going to be kt plus c, so it's going to be 3t plus c. We'll leave the c on the other hand, because the derivative of 3t is 3 if t is the variable. integral of 1 over t is ln. We cannot use the power rule because t has a -1 exponent. It's ln. That's 6t to the -2 plus 1 over -2 plus 1 plus c. So it's 3t minus ln of absolute value of t. That's 6t to the -1 over -1, so minus 6 over t. Example 3. What's the antiderivative of secant theta tangent theta minus 2e to the theta d theta? Again, we're going to split it up. Secant theta tangent theta, the constant d theta, the constant will come out. We know that the integral of secant tangent is secant. Okay, so secant theta minus 2, integral of e to the theta d theta is e theta, and then add the constant at the end. Okay, number 26, page 362. How do we find the most general antiderivative? So basically we want to do antiderivative of x squared plus 5 over x squared plus 1 dx. Again, we don't have a quotient rule, but we can break this down by doing long division. 2x squared plus 5 over x squared plus 1. 2x squared divided by x squared is 2. Distribute the 2, so 2 times x squared, 2 times 1. Switch the signs because we're subtracting. 5 plus -2 is 3. So this is 2 plus 3 over x squared plus 1. Let's see if it's easy to antiderivative that one. Plus 3 over x squared plus 1 dx. Well, we split it up. Integral of 2 dx plus 3 is a constant. Integral of 1 over 1 plus x squared, or x squared plus 1 dx. Now this is 2x plus c, as we know. We know that derivative of tangent inverse is 1 over 1 plus x squared, so antiderivative of 1 over 1 plus x squared, right there, is tangent inverse x plus c. And don't forget to add the constant. Okay. So next, in this same section, section 4.9, we're going to do a little bit about differential equations. Of course, we can't do a lot. If you want to do differential equations in depth, you can take a lot of classes. So what are those differential equations? They're equations that involve derivatives. Okay, it could be first derivative, second derivative, or combination of them. Okay, so an equation that has any derivative in them is called differential equation. For example, y prime equals 2x, y double prime plus y prime equals x minus x squared, and so on. These are all called differential equations of a differential equation is to find the original function y or f of x by anti-differentiating. Because if you're given the derivative, how do you go back to y? You anti-differentiate. For example, solve the differential equation f double prime of x equals x to the 6 minus 4x to the 4 plus x plus 1. Remember, we got the second derivative by we don't have the function, but by differentiating the function f of x twice. To go backwards, don't forget what antiderivative means. It's a function whose derivative is the original function. So going one way you differentiate, going back you anti-differentiate. So if we antidifferentiate, so to find f prime of x by going backwards, we antidifferentiate x to the 6 minus 4x to the 4 plus x plus 1. Okay, so now this is going to be integral of x to the 6 dx, pull the 4 out, and then x dx, and then 1 dx. So your power rule would be x to the 7 over 7 minus 4x to the 5 over 5 plus x squared over 2 plus 1x plus c. Okay, so that's one step backward, then another step backward, another step back. So going back, you antidifferentiate, going forward, you differentiate. So f of x is, again, antiderivative of x to the 7 over 7 minus 4x to the 5 over 5 plus x squared over 2 plus x plus c dx. Alright, so we're going to split it up and pull the constant out in the meantime, so we can antidifferentiate 4 over 5 x to the 5 dx, 1/2 x squared dx plus integral of x dx plus integral of c dx. So 1 over 7 x to the 8 over 8 minus 4 over 5 x to the 6 over 6, 1/2 x cubed over 3 plus x squared over 2 plus cx plus k. Remember, integral of k dx is kx plus c. Okay, so let's get up x to the 8. 7 times 8 is 56. Now we can reduce the 4 with the 6, so we get 2x to the 6 over 15 plus x cubed, 2 times 3 is 6, plus x squared over 2 plus cx plus k. Alright, sometimes we could actually find those constants if they give us what we call initial condition. For example, if we say find f of x, if f prime of x equals 5x to the 4 minus 3x squared plus 4, and they're giving us what we call initial condition. Basically, to find f of x, we're going to go backwards one step. So f of x is integral of 5x to the 4 minus 3x squared plus 4 dx. Split it up and pull the constant out. Minus 3 integral of x squared dx plus integral of 4 dx. So f of x is 5x to the 5 over 5, which is x to the 5, minus 3x cubed over 3, which is x cubed, plus 4x plus c. And this gives me every function whose derivative is the original function. If I want a specific one, I don't want all of them. I want the one that passes through the point -1, 2. That's what f of -1, 2 means. So of all these functions whose derivatives are this, I want one that passes through -1, 2, so I'll have to find the constant. When x is -1, y is 2. So y is 2 when x is -1. We plug that in to get c. So -1, that's negative times negative is 1, minus 4 plus c. So c is 6. And the function that you're looking for is x to the 5 minus x cubed plus 4x plus 6. This function passes through the point -1, 2 and has a derivative of 5x to the 4 minus 3x squared plus 4. Okay, there's a similar one I want you to do. And the solution is in the notes, number 44, page 362. So please do it without looking at the notes, then check it with my notes. Okay, let me do 52, page 362. 52, page 362. It says find f, again, find f, where f double prime of t equals cube root of t minus cosine t, and they give us two initial conditions to find two constants. Well, maybe not, we'll see. F of 1 is 2, f of 0 is 2, and f of 1 is 2. Let's see why they gave us two conditions. So this is t to the 1/3. So to go back one step, we're going to do antiderivative. So f prime of t is rho of t to the 1/3 minus cosine t dt. We're going to split it up. Minus integral of cosine t dt. T to the 1/3 is, you're going to add 1, so it's going to be 4/3. And instead of dividing by 4/3, we're going to times the reciprocal. Integral of cosine t is sine t and plus c. That's f prime of t. Now to find f of t, we'll go back one more step. So f of t is, we're gonna integrate, pulling the constant out, splitting it up. So I'm saving some work, plus c dt. So f of t equals 3/4. We add 1 to that, it becomes 4/3 plus 1 is 4/3 plus 3/3, which is 7/3. And instead of dividing by 7/3, we times by the reciprocal. Integral of sine is negative cosine, plus integral of c dt is ct plus another constant k. So this is 9/28 t to the 7/3 plus cosine t, because you have two minuses, plus ct plus k. So now let's see how we can find c and k. We got two conditions, f of 0 equals 2. Let's see what we get from that. 2 equals 9/28 times 0 plus cosine 0 is 1. C times 0 is 0 plus k. So 2 equals 1 plus k, so k is 1. We got k equals 1. Let's try the second condition. F of 1 is 2. So we get 2 equals 9/28 times 1 plus cosine 1 plus c times 1 plus ck, but we already found k to be 1. So 2 minus 9/28 minus cosine 1 minus 1 equals c1. So c1 equals whatever that number is. Let's see what that number is. 2 minus 9/28 minus cosine 1 minus 1. So it's roughly 0.14. Okay. So now one more thing from this 4.9. It's a long section. We're going to talk about rectilinear motion, which we've already discussed several times in math, but I don't know how much you remember of it. Remember the position function, s of t equals 1/2 at squared, where a is gravitational acceleration, 0 is initial speed, and s0 is initial position. And you find the derivative of s of t, it's the velocity, which is going to be at plus v0. So v is the derivative of s, so s is an antiderivative of v. And also a of t is the derivative of v of t, right? So if you find the derivative, you get a, as you can see. So v of t is antiderivative of A of t. So basically, this is what I'm saying here. If I'm given V and I want to find S, I will do antiderivative, okay? And if I'm given A and I want to find V, I would do antiderivative, just working backwards. Remember, S is the position function, V is the velocity, and A is acceleration. It's all in the notes, okay? So let's look at 66, page 363. 66, page 363. It says particle is moving with the given depth of the position, so that we want S of t. We're given V of t is t squared minus 3 root t, and we're given initial condition S of 4 is 8. So S of t is the antiderivative of V of t. We're going to write root t as t to the 1/2. We're going to split it up and move the constant out while we're splitting it up. So it's t cubed over 3 minus 3 t to the 3/2 times 2/3 instead of dividing by 3/2 plus c. So S of t is t cubed over 3 minus 2t to the 3/2 plus c. Now S of 4 equals 8. So that's going to find us c. So 8 equals 4 cubed over 3 minus 2 times 4 to the 3/2. So you can figure out that c is 8/3. Okay. Let's look at 68, page 363. We are given acceleration and we want position, so we get an antiderivative twice. 3 cosine t minus 2 sine t. We're given S of 0 equals 0 and V of 0 equals 4. So we're going to go back one step to find V of t, which is antiderivative of A of t, dt. So it's 3 antiderivative of cosine t minus 2 antiderivative of sine t dt. So 3 sine t minus antiderivative of sine is negative cosine, so that will be plus, and then plus c. So let's find that constant. Since V of 0 equals 4, so we get 4 equals 3 sine 0 is 0, 2 cosine 0 is 1. So c is 4 minus 2, which is 2. Let's put it back in there. So 3 sine t plus 2 cosine t plus 2. Now remember, V is not our final step, it's S, so go back again. S of t is antiderivative of V, which is 3 antiderivative of sine t plus 2 antiderivative of cosine t plus antiderivative 2 dt. So negative 3 cosine t plus 2 sine t plus 2t plus c. But S of 0 equals 0. So we get 0 equals negative times 1 plus 2 times 0 plus 2 times 0. So c is 3. And let's write our final answer. S of t, negative 3 cosine t plus 2 sine t plus 2t plus. Okay, I want you to seriously look at 82. Look at that. And I want you to understand that, because I might have something like this on the test. If you have any questions about it, shoot me an email. I'm done with 49. Have a good day.